All right, so here's our review. So we're going to start with graphing our exponential and logarithm functions. So the way we did it in class was we basically graphed the simple version of this. So that would be y equals 2 to the power of x. And then we use transformations to move it. So let's just kind of review what that table looks like. And then we'll use our transformations. So if I plug in like 0, 1, 2, 3, so I'm raising 2 to that power. So 2 to the 0 power is 1, 2 to the 1 power is 2, 2 squared is 4, and 2 to the third power is 8. So you'll notice the pattern is that it kept doubling, right? So if I go in the other direction and I go from 0 and count down to like -1, -2, I'm going to go in the opposite direction. I'm going to go from a 1 to a 1/2, and then from a 1/2 to a 1/4, and you just keep taking half of what you have there. And the way we'll kind of deal with that when we start graphing is notice that that's where our asymptote is, our horizontal asymptote. It's going to be at y equals 0 in the case of this original function we have right here. Oops, too far. Okay, so our graph is a little different though because we have that -1 right there. So that's going to cause a transformation to the right 1 unit. So what we're going to do is take these points right here and move them all to the right one. So right 1, and at 1, 2, we go to the right. Then at 2, 4, we go to the right. And then at 3, 8, we go to the right. And then I'm not really going to worry about these other ones because the asymptote will guide me there. Okay. So the asymptote does not move in this particular example because we didn't shift up or down. So that's the only thing that's going to move your asymptote is if you shift up or down, or possibly if you throw in a reflection with that. But we're not going to have anything too complicated that you'll see here. So on the right end, you just kind of follow the points as they just kind of go off really fast up. And as we come down, you just go toward your asymptote, and then that's fine right there. Perfect. Um, the range on this, so the range would be from 0 up to infinity. Okay, so the difference on the next one is we have a +2, so that's going to cause us to go up 2, and our horizontal asymptote is going to go up 2 also, so it's going to be at y equals 2. We can go ahead and put it right there. Okay, now once again, we'll take the table of the blue points and we'll shift them all up 2. Let's see, at 0, 1, now I'm at 0, 3. Different color. There we go. Then at 1, 2, now I'm at 1, 4. Then at 2, 4, now I'm at 2, 6. 3, 8 is now at 3, 10. And then once again, we just curve going up just like that. Curve going down just like that. Now this time our range is different because now we're going to start at -2, but not including it. And then we go up from there to infinity. Okay, so that's our exponential functions. Okay, like I said, I kept it pretty basic. They just had signal transformations, so nothing too crazy. Okay, so the next one we're going to look up is the logarithm ones. Now those are actually just the inverse function of exponential. And you can kind of use that fact to help you graph these if you'd like, especially if they start to get kind of complicated. But these, they're fairly simple. So kind of like the previous one, what we'll do is we'll look at a very simple version first. I'll put it right here in the middle. So y equals log base 2 of x. And so on your exam, you'd probably do the same thing. If it's base 3, then do base 3 or whatever. And so we're going to make a little table here. Okay, and so if you do want to go ahead and convert this to exponential form, this would be 2 to the power of y equals x. And so it might be easier actually to plug in some values for y. like 0, 1, 2, 3. And so when you do that, to the power of 0, that means my x value comes back as a 1. 2 to the power of 1 is 2. 2 to the power of 2 is 4, and then 8. And so if you compare it to the table up above, you'll just notice that the x and y values were interchanged. And that's part of the definition of our inverse function. So the same thing would happen with these other values we have right here, the negatives and the fractions right there. So like for y, if you plug in a -1, you have to take the reciprocal and you get a 1/2, and so on. If you plug in -2, you get a 1/4, and so on. But once again, as far as our graph, we're going to kind of focus on these because you will have a vertical asymptote in this case. Okay, the original vertical asymptote for this basic one is at x equals 0. So if we shift left or right, then the asymptote will shift with that. Okay, so on this first one, we actually do shift. We're going to shift to the right 2. We'll shift right 2. So we'll take these points. Oops, I got shifted. Okay. So let's see, go to the right 2, and then let's see at 2, 1, go to the right 2, and then let's see at 4, 2, we go to the right 1, 2, and then we have 1, 8, 3, and we go to the right 2, and then that vertical asymptote is going to be at x equals 2. And so when you graph this going up and to the right, just like that, and then when you come down, just use that asymptote as a guidance. Okay, now because of that, our domain, the x values go from 2 to infinity. Okay. All right. Now, if you look at this other one, we have -1 plus the log base 2 of x. And so that's actually going to cause us to shift down 1 unit. The vertical asymptote, nothing got adjusted on that, so that's still going to be at x equals 0 of the original function that we're using transformations for. Okay, so we'll go ahead and my asymptote stays where it's at. And all the points from this table, we're going to shift them down 1 unit. So let's see, 1, 0, now we're down. Let's see, 2, 1, go down. 4, 2, go down a unit. And then 8, 3, we go down a unit. All right, so curve it going up, like that, going down, like that. The domain on this one just is from 0 to infinity, right there. Okay, so that's graphing exponential and logarithmic functions.